All right, I think I'm live. Hello, you wonderful people, you. I miss you all so much. We just got the news. We just got the news yesterday that school will not be reopening this year. Okay. Well, I was really saving this lesson. This lesson is kind of special. It's kind of special because it's one of those things in geometry. It's that part of geometry where it actually comes in handy in like real life situations. It is useful to know things like area and perimeter and circumference and the area of a circle. And you might think to yourself, why would I ever need to know this kind of stuff? Well, I mean, gosh, I mean, from anything from understanding how big apartments are. You know, apartments are measured in living spaces and houses, and any place you want to live is measured in square footage of internal space. Um, they measure the outside footprint of the house, and they make a calculation based on square feet, and that's how they compare the size of the living space between different houses. But for square footage, it also comes into play when you're talking about like when you buy grass seed to plant a lawn. I'm looking at let me bring. Hey, I have a prop. I didn't even know I was bringing this prop. I got this bag of grass seed right here, right? And notice that it says 5,000 5,000 square feet. So I got to calculate when I choose when I choose my bag of grass seed. I got to kind of give a rough calculation of how many square feet of grass do I need to replant here, and how much grass seed do I need to buy to make sure the lawn looks okay this year. All right, and then maybe maybe there's all sorts of reasons why you might want to know square feet and area and perimeter. If you're building a fence, right? The fence usually goes on the outside boundaries of your property, and sometimes they call that a perimeter fence. And so you need to calculate the perimeter of how much fence you need to buy to cover the job. So there's all sorts of interesting little ways that these geometric measures will come in handy. I'm trying to think about the circle stuff, the circumference of a circle and the area of a circle. You don't often run into those. Nothing I can think of off the top of my head. Um, I'll keep my brain on that. So let's get started, shall we? All right, I'm about to do my motion picture magic. Ready? Okay, here goes. All right, there we go. The motion picture magic. I've got to show you my screen, and there we are. Actually, you know what? I am going to do the student version of this. The student version of this, so you can sort of look the same for you. All right. Hopefully it'll look the same for you. So when you get yours, when you open up your lesson, it'll look something like this. This is Geometry, Unit 1, Lesson 6, all right? And this lesson's called Using Formulas in Geometry. Using formulas in geometry. So here's our learning target. Our learning target today is I can apply formulas for perimeter, area, and circumference. So I want you to be able to apply formulas for the perimeter of squares, rectangles, triangles, and circles, um, along with area and circumference. Actually, perimeter is used for polygons and circumference is used for circles. I misspoke there. All right, so you're going to put your name down over here. You're going to try to put the learning target in your own words. In your own words, if you can. If you just cut and paste, that's fine too. I just want proof that you've actually looked at the learning target when you do these. And let's see. Okay, so some vocab review. So before we get started, let's talk about what is perimeter. I kind of already talked about it. The perimeter is the border or outer boundary of a two-dimensional figure. All right. So for instance, if you had a square where each side is 1 foot and each side is 1 foot in length, then the perimeter would be 4 feet because you'd have 1, 2, 3, 4 lengths of 1 foot. 4 times 1 is 4. You have a perimeter of 4 feet. All right, that makes sense. Area. Area, in this sense we're going to be using it today, it's the quantity of two-dimensional space or surface. So if you had that square that has each side length is 1 foot, you'd have a 1 foot square of amount of space because you'd have 1 times 1, you'd have that much area. You'd have 144 square inches, wouldn't you? How did I convert from 1 square feet to 144 square inches? Well, there are 12 inches in 1 foot, right? 12 inches in 1 foot. Take a look at a ruler if you don't trust me on that one. 12 inches in a foot, so I have a 12 by 12 by 12 by 12 square. 12 times 12 is 144, so I have 144 square inches in that 1 foot square amount of space. We'll go into that more. Don't worry if that's confusing. I probably shouldn't have thrown that little complication in there too early at you. All right. So we talked about perimeter. It's the distance that goes around a polygon. Area is how many like square feet, square inches, square centimeters. It's amount of space, two-dimensional surface space of a figure. And then base. Okay, so base. A base in geometry, usually we're talking about triangles, and the base can be any side. All right, the base of a triangle can be any side of a triangle can be called the base. So you just pick a side, you call it the base. Once you call it the base, then you can determine the height. All right, the height is a line that connects perpendicular to the base all the way to the vertex of the other side. So if you had a triangle like this, you would call the base, usually call the base the bottom, whatever side's on the bottom of the page, oriented down. Usually we call that the base, but any side can be the base. And then a perpendicular line, which means it has to intersect with the base 90 degrees and connect with that vertex. If you're having trouble visualizing that right now, don't worry. I got pictures. We're gonna just trying to preload the vocab in your head. So somebody got some of these words bouncing around in there, and then you'll see pictures of it, and it'll all start to just fall together and click together. Okay. All right. So just preloading the vocab here. Let's talk about diameter. So diameter, it's a segment that has the endpoints of a circle. So if you have a circle, the diameter is all the way across and through the center, right? If you have a circle like this, then the diameter is a segment all the way across and through the center, okay? So the diameter is going to be like the distance of 2 radii. So here we have what's called a radius. A radius is a segment that starts in the center and goes to the outside of the circle. So if this is my center of my circle, my radius goes from the center to the outside of my circle. Now, this could be a radius, or that could be a radius, right? Any of this could be a radius. And then 2 radii together that form a straight angle, that's a diameter, all right? And then the circumference of a circle is the distance all the way around. So if we talk about the circumference, we're talking about that length. If we had a string and we wrapped it all the way around the circle, what would be the distance of that? That's the circumference. And then pi. I can't remember if I talk about pi too much in this one. 3.41. If you got your calculator, and maybe I should just throw you, I'll throw my calculator while we're talking about it. So pi is this magic number, 3.14. It has a lot more digits than that. Every now and again, I will try to memorize a whole bunch of digits of pi. And right now, I can't. At one point, I had up to 10 digits of pi memorized, and I can't come up with it right now. Now all I can remember is 3.14. So, but let me show you. You don't have to have it memorized. It's right here on your calculator. Let's find it here. We're looking for that little pi symbol. Oh, there it is. You see how I found it right there, that little pi symbol? So you notice how it's in blue there. It's in blue. So I'm going to press second and that blue pi symbol. And that's what it looks like when on my calculator. If I press enter, that's the magic number pi. And this magic number pi, given the radius, will show us the circumference and the area of a circle. So we'll get into that. I'll show you more about formulas about that. But first, we already preloaded the vocab, so here's some warm-ups. I'm not going to go over these warm-ups. I'm going to give you a chance to answer these. I kind of already talked about them in the vocab, so I'm not going to go over them. So just pause here and answer these 4 questions. All right, you're pausing the video and you're answering the 4 questions, and then you're going to unpause the video. Great. You finished, you paused the video, and now we're moving on. You finished these 4 warm-ups. So let's talk about perimeter and area some more. All right. If you had trouble with one of those warm-ups, maybe what you're about to see right now might help you, kind of get into gear here. All right. So perimeter. Perimeter is the distance all the way around. So if I am calculating the perimeter of a rectangle, I got to count the distance of this side, that side, this side, this side, right? So it's this plus this plus this plus this. But the thing about rectangles, we know something about them, right? We know in a rectangle that opposite sides are the same length, right? This side is the same length as that side. This side is the same length as that side. If that wasn't true, then this wouldn't be a rectangle. But if it's a rectangle, we know this to be true. Well, if we know this to be true, then we don't have to actually count up all the side lengths. We can actually say 2 times the length plus 2 times the width will give us the perimeter. And so here's a little formula for that. 2 times the length, this kind of cursive L, plus 2 times the width gives us the perimeter, okay? And then area. Area, you remember area? It's just length times width. So I would take whatever the number is, the quantity of this side length, and the quantity of this side length. I'd multiply them together. Length times width. Length times width. And that gives me the area. Give me the square inches or square feet or square centimeters of whatever this figure here is. All right, square. Square is actually kind of easier to figure out the perimeter because with a square, you know that all four sides are the exact same length, right? If it's square, then all four sides have to be the same length. So to find the perimeter, you just got to add up, this side plus this side plus this side plus this side. So if this side was, it looks like a 5, but it's really an S. Oh, sorry, it's 9 o'clock. So that's going to ding 9 times. Oh, golly, I'm not sure what I should do while it dings. It's kind of distracting to me. I imagine it's distracting to you. Apologize for this. This is the dangers of in-home, in Mr. Solt's study lesson planning. All right. I'm just going to let it ding a few more times. So, sorry, you can just fast forward, 5 seconds. It takes a... All right, it's done. Okay, where were we? Oh, yes, we talked about the perimeter. Now, I said you could add up all four sides, but once you knew the length of one of these sides, you could just multiply it by 4, and you'd get the perimeter of the whole square. So that's what this formula here says. It says the perimeter is equal to 4 times the length of S, with S being the length of one side, right? 4 times whatever the length of one side is, that's going to be the perimeter. It's like adding all four sides up. And then area. Area is going to be the side squared. Side squared. Can I see why that is? Because if the area of a rectangle is length times width, it's one side times another side, then the area of a square is just actually the side times itself. One side times, so if this was, say, 6, it'd be 6 times 6, and that would give us 36. That's the same thing as 6 squared. 6 squared is 36. Same idea. It's just a little bit slightly different notation. Yeah. And that would give us the area of this square. And then triangle. Triangle, have you ever noticed that a triangle is a lot like a rectangle? Now you might say, Mr. Soul, a triangle is nothing like a rectangle. Well, sort of, right? Do you see what I just kind of did just now? Do you see how I've kind of I took this triangle and then I drew out like a side length here and then a side length here, and I kind of created a rectangle, right? To get all together, this side is probably the same, should be the same as length as that side. These two side lengths should be the same. Maybe my diagram's a little bit off. I tried to make it as rectangularly as possible, but do you see how really every triangle can be created, like any triangle at all? Just trying to create a random triangle here. I can create a rectangle out of this thing, right? If I go at 90 degrees and 90 degrees, that's not the best, is it? I think this one's off a bit. I wonder if I can, no. Oh well, we kind of see what I'm doing. I'm trying to create a rectangle out of these triangles here. Well, if every triangle can be formed into some kind of rectangle, then, well, some interesting things happen, right? Because if I know that a rectangle is length times width, and I know that any triangle is half of some other rectangle, well, then I could take, I could kind of use that to kind of figure out what the perimeter or area is on these things. So, for instance, the perimeter of this triangle here is going to be A plus B plus C. Now that you're just going to have to add these 3 up because the side lengths of a triangle are not always in a particular proportion based on the angles. If we were just talking about right triangles, we might be able to say something a little bit different about that. But given the fact that not all triangles are right triangles, to find the perimeter of any triangle, you're just going to have to add up A plus B plus C. Add up all 3 sides. You have to find all 3 side lengths to find what the perimeter. Now, we'll eventually get into this point where if this is a right triangle, if it's a right triangle, which means there's a right angle right here, right? If this thing here is a right angle, then I could find B. If I knew A and I knew C, I could find B. I could also, if I knew A and B, I could find C, right, with that Pythagorean theorem. Remember that? Oh, I'm writing with my mouse now, and it's very awkward. I don't know why I didn't go grab my drawing pad right before I knew I was going to do this. All right, sorry about this. Let me get my drawing pad so that this I can draw like I'm not in second grade, right? All right, so this is the Pythagorean theorem right here, the Pythagorean theorem, and that's if it's a right triangle. This thing only works on right triangles, okay? All right, and then to find the area of a triangle, I'm going to kind of use this idea of it being partly a rectangle, and I'm going to use base times height divided by 2, right? Or base times height times 1/2, which is really the same thing as dividing by 2. Multiplying something by 1/2 is the same thing as dividing that thing by 2. Do you see how 1/2 is really 1 divided by 2? And if I times this, right, if I times 1 times base times height, 1 times anything is really the same thing as itself. So the 1 kind of disappears over here, and this becomes base times height divided by 2. So I'm trying to think of an example. Let's call the height 5, equals the height. And the base here is going to be equal to 12. So what I have to do is I have to take base times height divided by 2. 1/2 base times height is going to equal the area of my triangle. And that means I know that the base was 5. So instead of B, I put in 5. And instead of H, right, I know that, wait, there we go. Instead of, no. Did anyone see I made an error there, right? I led you wrong. Let me rephrase this. Okay, the height is 5. I said the height was 5. See it right there? That's what I said. The height was 5. I said the base, that's supposed to be a B there, is 12. So I just put these numbers in here, in for the numbers that I said they were. And I had 1/2 times 12 times 5 is 30. How did I know that? Off the top of my head, well, I know that 12 times 5 is 60, and then half of 60 is 30. You can kind of use those mental little tricks to solve, break things down. So the area of this triangle, if the height was 5 and the base was 12, would be 30. All right, does that make sense? We'll get into way more examples in just a little bit. Don't you worry. I won't leave you hanging. All right, and keep in mind that the base can be any side of the triangle, right? Usually we orient it towards the bottom. Usually the base we call that whatever side is oriented towards the bottom of the page, we call that the base. But it could be, just so you're aware, it could be any side. Another thing to kind of be, the tricky thing about bases is that, the tricky thing about heights. Tricky thing about heights is that the height has to be perpendicular to the base when you're measuring it, right? And that comes in, if the triangle looks like this, that's pretty easy to do because you just find the line, the segment that goes down directly to the base and intersects at a right angle. But what if you get a situation where you don't have the base doesn't intersect with a vertex at a right angle? Well, what you got to do is you got to kind of extend an imaginary line out. You have to extend an imaginary line out and say dot, 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 dot. If the base kept going, then what would be the height from perpendicular to the vertex to the base? So keep in mind when you measure that height, it has to be perpendicular to the base when you measure that height. And if it's a triangle that looks like this, you got to extend the base out a little bit. That gets a little tricky. That'll always trip up a student or two on a test. They see a triangle like that and they panic. They're like, I don't know how to find the base. Well, you got to extend the base out a little bit. You take your ruler and just make sure the base, gets a little bit longer so that you can drop a line with a 90-degree perpendicular angle with the base. All right. Okay. So here's just a little review on how to find perimeter and area. I know we already talked about it. If you find this redundant, you can just fast forward. It's okay. It's always okay. I'm not going to take it personal. Not at all. Why do I provide it? An explanation of something 3 times. So it kind of like you kind of get some familiarity with it, and then you kind of see it again. You're like, okay, all right. And then the third time, I'm hoping it clicks, right? So this is the third time I'm talking about perimeter and area, hoping that, okay, you're seeing how this works. All right. So here's the situation. I got to find the perimeter and area of each figure. So a rectangle in which the length is 17 and the width is 5. So I always recommend when doing problems like this, sketch a little diagram. Now this is an awful looking rectangle. I understand it's an awful looking rectangle, but it doesn't matter. It's just a sketch, okay? It's just a sketch that will help me visualize what's going on. So I'm going to make the length 17. I'm going to make the width 5 because of, like I said, 17 and 5. And then I kind of got to remember the formula that the perimeter is going to be, all four sides added up. Well, that's something I know about rectangles. I know that this side is the same length as this side, and this side is the same length as that side, right? So if this side's 5, that's got to be 5. If this side's 17, this side's got to be 17. I could add all four of these things up, right? I could go to my calculator. If my calculator wants to go and turn on. There we go. And I could say, well, 17, plus 5 plus 17 plus 5 equals 44. All right, I could do that. It's totally legit. There's a faster, easier way. It's like a little math shortcut, right? I don't have to add up all four of those things. I can say 17 times 2, because I know there's two 17s, right? Plus 5 times 2, because I know there's two 5s. 44. Same thing. All right? You pick however way you're more comfortable with. That's fine. Take the shortcut. I recommend the shortcut. If you don't like the shortcut, fine. Just do it. Figure it all out. Add them all up. No biggie. Okay? All right, the area. How do I find the area? Remember, area is length times width. Length times width. All right? So, area now. Well, length times width, this is going to be 17 times 5. All right? And 17 times 5 is 85. I didn't do that in my head. I saw it right down here, okay? I would normally break out a calculator just to be sure. I could probably, if I thought about it long enough, I could maybe do it mentally in my head, but why stress your brain out with all that, right? That's what a calculator's for. All right, so now I've got to find the perimeter and the area of a triangle, right? Remember what I said about diagrams or sketches. This is actually a sketch because it's not perfect or by any means. It's just a rough sketch. All right, so it's going to tell me a triangle in which A is 8, B is x plus 1. Wait, what? And C equals 4x. Okay, let me try this out. So A is 8. I'm going to call this side A. And then B, I'm going to call this B because it's for base. And I know it's x plus 1. And then C is going to be 4x. Oh, okay. And the height is going to be 6. So if I drew a perpendicular line in this triangle that was perpendicular, that would be equal to 6. All right. All right, so let me figure out. So the perimeter, I got to add all these things up. So I would have 8 plus x plus 1 plus 4x, right? And I'm not going to be able to figure out exactly the exact number for this because I've got variables going on here, but I can combine some like terms. So I know that 1 and 8 combined form 9, and I know that 1x plus 4x will give me 5x. So you see how they did that right there? They just took the like terms and they combined them. It's called combining like terms. So the perimeter then, the perimeter of this triangle is going to be called 5x plus 9, which merely means we still don't know the true perimeter of the triangle, but we know it's got to be 5 times x plus 9, whatever x is. All right, and moving on to the area. Remember, area is 1/2 the base times height of a triangle. Okay, so I know that the height is 6. I know the base is x plus 1, so I'm going to have to be 1/2 times x plus 1, the base, times 6. Well, I'm going to have to multiply all these, so this gets a little tricky. They just give you the answer, 3x plus 3. But I'm going to multiply these two first, right? I'm going to show. This is just a little algebra reminder of how to multiply binomials, right? This is a binomial here with a monomial. Okay, so the trick is, here's what a lot of students do. This is the wrong answer. They'll have 6x plus 1. What they'll do, again, wrong answer. This is not equal. What they'll do is they'll say, well, I know that 6 times x is going to be 6x, and I see x plus 1 here, so it's 6x plus 1. But here's the funny part. Here's the funny part. These little symbols right here are parentheses. Those little symbols are parentheses. What they mean is that that whole thing is it's together. They came to the party together and they're leaving together, okay? You can't separate them out. This is an expression, and this is only the 15-minute bell, so it's going to be real short. So I can't just take 6 times x and do 6x. That is part of the answer there. 6 times x is 6x. But if I multiply 6 times x, I got to also multiply 6 times 1, which gives me 6x plus 6, which is different than 6x plus 1, okay? And now I know that x plus 1 times 6 is 6x plus 6, and now I got to multiply this whole thing by 1/2, or divide by 2, however you like to look at it. So again, that next little step would be for me to then divide this whole thing by 2. Well, 6 divided by 2 is 3, which would give me 3x. 6 divided by 2 is 3. And that's how they got 3x plus 3, right there. All right? Okay. Let's keep on keeping on. All right. I'd like you to find the perimeter and area of a square where the side is 3.5. And I recommend that you do a sketch. Now, this is an awful square. I understand. But here's a little sketch of this square. This little hash mark symbol, I put one on each side. That means that each side is the same length, okay? All right. And that means that all the angles are 90 degrees. I want you to find the perimeter and area of this square here with a side length equal to 3.5 inches. All right. Now, I want you to pause the video. I'm actually going to answer this one for you because we're just warming up here. I want to answer it, but I want you to pause. I want you to try this one on your own. Give it a shot. All right. Pause, and then do it, and then unpause. All right. Great. I hope you paused. I hope you gave this a shot. You learn by making mistakes. You learn by trying. I really encourage. I encourage even the wrong answer, because you learn more even when you learn more when you make wrong answers, because there's a part in our brain that helps us. It helps us learn whenever we're surprised, and whenever we get the wrong answer, we're just a little bit surprised. We're like, oh, okay, it's the other thing. Oh, okay, that little like, oh, okay, I got it wrong. That actually opens up your brain to be like, wait, I need to learn something here. If you get it right automatically, you don't learn as much because you already knew it. So okay, let's talk about the perimeter. Perimeter, I got to do this plus this plus this plus this, or the shortcut is just multiplying it by 4. All right, so 3.5 times 4. What's that equal? Well, I'm just going to go to my calculator. I just figured out it was 14, but wait for my calculator's not going to show up unless I switch to my Hello, Mr. Calc, and my calculator's going to take a minute to initialize. 3.5 times 4, 14. Do you see that? Do you trust me? 14, okay? No, Mr. Calculator, I want you to stay there. I don't want you to go on the other side of the screen. Okay, so it's 14. And then someone might say, well, Mr. Sold, how did you do that so fast in your head? Well, I used a little math trick, right? I knew that 3.5 times 2 was going to be 7, right? Because 3 times 2 would be 6. 2 1/2 would be 1. So 6 plus 1 is 7. So I knew that 3.5 times 2 is 7. And then times 4 would be double that. And I knew that 7 times 2 was 14. So that's a little math trick I used to find that kind of fast. Probably not as fast as some of you. Maybe some of you had it found out a lot faster. I'm myself, I'm a slow math thinker. I just kind of plod through one step at a time. All right, so this is the perimeter. So perimeter here, if you were answering the question, you'd say P equals 14 inches. Now, I am not going to freak out if you don't put the inches on there all the time. I'll always mention it to you, but I'm not going to like take off for you forgetting. Other more, let's say, type A personality math teachers, they really, really want you to add the units, all right? That's real important because if you get those wrong in real life, you can really mess things up. So that's just always an important skill just to remember and keep in mind. Okay, and then let's do the area now. Area. Well, the area, remember the area of a square or rectangle is going to be length times width, or in case of a square, it's going to be a side squared. So 3.5 times 3.5 is the same thing as 3.5 squared. Now, a lot of you knew that, but I always like to write it so you can visualize what's going on. It's 3.5 squared, which is the same thing as 3.5 times 3.5. And I need to switch my cursor in order to get this thing to switch. Oh, and I do want my calculator to go on the other side of the screen now, so I'm not blocking. Anything. Oh, and maybe my big head is in the way here. I'm sorry about that. I sometimes forget that my big head is in the lower right-hand corner of your video. Let's see here. I need 3.5 squared. 3.5 squared. 12.25. Okay, 12.25. So back to the pen. So the area is 12.25. Area 12.25. And remember, some of those picky math teachers are going to want this. So the perimeter is a measure of length, right? So it's just 14 inches. But area is a measure of inches or units squared, okay? So this is square units. This is 12.25 square inches, all right? That's amount of surface area. So that's how, hopefully you got the same. If you got these, congrats. Well done. Good on you. Fantastic. I'm impressed. If these were a little bit harder, that's okay. You will get lots of practice. And you know, I always struggle. I always want to make this relevant. And geometry is really, really the way the curriculum's written. It's about teaching you logical thinking skills. That's really what it's. We're playing with shapes and math, but what really the curriculum is stressing is logical thinking. So sometimes some of these things are pretty abstract. The real thing they want you to learn, and there's not so many applications. So, but I try to find applications where I can find them. All right, and if some of these are stretch, you know, sue me. So you know, there's this place called the Texas Treasures Quilt Block. All right, so this is a Texas Treasures Quilt Block in Texas. This is like I don't know, some kind of Texas quilt. I don't do quilting, but apparently this is some kind of pattern that has a specific name called the Texas Treasures. And it includes 24 purple triangles. The base and height of each triangle are about 3 inches. Find the appropriate amount of fabric used to make 24 triangles. So if we needed, like if you were quilting, you might actually need some geometry to figure out how to get these 24 purple triangles here and how much fabric you'd need. So if the base and height of each triangle is 3 inches, then you are going to need, well, base times height times 1/2 is going to be the area. So 3 times 3 is 9. 3 times 3 is 9. 1/2 of 9 is, 4.5. So the area of for one triangle is going to be 4.5 inches squared. And you know that there's 24 purple triangles. Therefore, 24 times 4.5 is going to be 180 inches squared. You'd have to go to your fabric or craft dealer and at least buy 108 square inches in order to finish your project. And this is where math can come in handy, even if you're not a quilter, because maybe you're doing a construction project or whatever. You don't want to buy more materials than you need, right? You don't want to spend more money than you need to spend, and you really don't want to make 2 trips and not buy enough materials that you want. So it gets kind of tricky sometimes in measuring area and lengths of wood or fabric or you need to buy exactly what you need. You don't want more because you don't want to spend more than you need, and you don't want to make 2 trips and have to go back because you need more material. So you want to be able to do the calculations up here or on paper in order to get stuff done. All right, we're getting stuff done. That's what it's all about. So I'm going to ask you to find the amount of fabric used to make 4 rectangles. All right. Each rectangle has a length of 6.5 inches and a width of 2.5 inches. All right. I would like you to pause the video as soon as I get done making this diagram. All right. I'm going to call it 6.5. I like decimals when it comes to these kinds of fractions. 2.5. All right. So I got a rectangle. And whenever I have a rectangle, I know that opposite sides are the same. Okay, the length is 6.5. The width is 2.5. I want you to find the amount of fabric in square inches that we're going to need for to make 4 rectangles. 4 rectangles. All right, pause the video now. Boop. Try this out. Great. Yeah, pause the video. Yeah, tried it out. I hope you weren't intimidated by this one. This one is not it shouldn't be intimidating, right? Because you know that what is area? Area is the length times width. I hope by now length times width is something that almost sounds automatic to you, right? It's the area of length times width should be hopefully getting to be automatic for you. That's how I calculate the area of a rectangle. Length times width. And here I go. I'm going to do the calculations now on a calculator. I don't like that black screen it shows me every time. I don't like that. All right, 6.5 length times 2.5 width, 16.25. I know that now some of you, if you wrote 16.25, you're darn close. You're darn close, but I'm not done, am I? Right? 16.25 is for 1 rectangle, but we got 4 of these guys, so we gotta do one more step. 16.5 times 4. Hopefully y'all caught that. If you didn't, that's why these problems can be a little tricky. It's that logical thinking that they really want to stress. 65. It's that logical thinking. They try to make sure that you're following the logical line of thought. And notice 65 inches squared. Notice I put the unit in there. I mean, like, again, it feels like geometry is all about shapes and all this stuff, but it's really about logical thinking. And that's a skill you can take anywhere. All right, let's talk about circles. Circles. All right, love circles. Circles are wonderful. Circles, they're just kind of special. Man, this makes me. I'm gonna put in some extra credit assignment sometime about the power of circles and arches and how strong an arch is. But for now, this is a circle. All right, and so this is the center point of a triangle. Sorry, of a circle. It's very important because we define a circle as all the points. So the circle is this out here, but the circle is defined as all these points that are equidistant, the same distance from a center. So once you pick the center of a circle and you know the radius, you know the distance from the center to one of the points on the circle, then you know the distance from the center to all of the points on the outside of the circle, okay? And this is what we're talking about, the difference between a diameter. A diameter is all the way across, going through the center, and a radius is just from the center to one of the outside points on the circle. It can be here, it can be there, any of these. One radius is a radius. Multiple plural radiuses is a radii, okay? It's a radii. I know that's kind of funky, just so you know that when there's more than one radius, it's radii, okay? So the diameter is this line that goes through the circle, through the center. The radius is from the center to the outside, and then circumference. Circumference is going to be all the distance all the way around the circle, okay? So this line right here is the circumference of this circle here, all flattened out, straightened out, right? If you could take the distance of 360 degrees of the circle and flatten it out into a line, that's what it would look like right there. It's going to be, you know, oof, sorry, a little bug in here. All right, and that's going to annoy me. It's going to fly around. Okay, so the circumference of C of a circle is given by the formula C circumference is equal to pi times diameter. Or, since a radius is really just half of a diameter, radius is half a diameter, you could say 2 times the radius times pi, right? It'd be the same thing. The diameter is really 2 radii together. Well, 2 times the radius, or 2 times the length of the radius times pi would also give you the circumference. And the area. The area uses a different formula called pi r squared. Now, sorry, that little fruit fly keeps swarming in on my line of vision. Distracted me. All right. So the area of a circle is the area is equal to pi r squared. So to kind of keep these two formulas straight in your head, r squared is going to give you the square inches or square units. It's going to give you the area of your circle. Well, it's 2 times the diameter, or 2 times the radius squared. Sorry. 2 times the radius times pi will give you the circumference. Oftentimes, you'll find you can just look these formulas up, with Siri these days, and Amazon devices and all these things. You can Google it, you can Siri it, you can ask your Amazon device these formulas. They're going to be on the back of your regions too, in the reference table. So you don't have to memorize all these, but I encourage you to try. It's sometimes handy to have these formulas in your head sometimes, but you could always go look them up. All right, so finding the circumference and area of a circle. So these are just notes. This is an example. All right, so I got a circle here, which is all the points that are 3 centimeters from this center here. So I know the radius is 3 centimeters. So how do I find the circumference? Well, it's going to be 2 times pi times the radius. Well, I know the radius is 3, so I just took the length of the radius right there. 2 times pi times 3 is the same as 6 pi, which is the same as, or 6 times pi, which is about, approximately, that's that little squiggle, 18.8 centimeters. So some of you are doubters. I know some of you are doubting Thomases. That's what I like about you guys. You don't trust me all the time. You want to see it for yourselves. You gotta visually see it. That's kind of cool, actually. So let's try this. 6 times pi. 6 times pi. Remember, pi is this little symbol right here, right? Is equal to 18.8495592. It keeps going, but they rounded it, right? They saw that there was a 4 here, so they said, well, we'll keep the 8 the way it is. It's just about 18.8. So you kind of see that? This isn't the exact answer. This is the more exact answer. They did a little bit of rounding. That's okay. The area is pi times r squared, okay? So our radius, r is our radius. 3 squared is 9. So this is really the same thing. The area is going to be 9 times pi. And if we go to our calculator, 9. Actually, I'm going to show you pi first again. There's pi. Pi equals that number, 3.141592654. Okay, very important number. And we're going to multiply it by 9, which will give us approximately 28.3 centimeters, right? 28.27. So they saw that the 7 was next to the 2 here. They're rounding to the tenths place. 7 is 5 or greater, so they rounded that 2 up to a 3, be 28.3 centimeters square. So I'm going to have you, I'm going to do a little sketch. I'm going to have you do this next one. Let me do a little sketch for you. I probably should stop doing the sketches, actually, because I want you to get into the habit of making these sketches for yourself. So they told us that the radius here is 14 meters. So I'm going to find the circumference and the area of a circle with a radius of 14 meters. Use this little notes area here as a reference. It's going to be the same exact problem, but 14 is going to be stuck in here instead of 3, right? Okay? We're going to stick a 14 in there. It's going to be meters, square meters, not square centimeters. All right? Should I do this one? Should I have you pause? Should I move on? Because it's our first circle, I'm going to do it. And then I'm going to start moving on. I'm going to have you do more of these, okay? So, pause me. Pause me now. Try it on your own. and we'll get back to I'll go over it. Great, great. You paused and you tried it, right? You tried it. I sure hope so. All right, it's real easy because I have this example right over here, right? The circumference is going to be 2 times pi times 14, right? Because the radius, in my case, here is 14. So 2 times pi times 14. Let me go to my calculator because I can't do that in my head. 2 times pi times 14. 87 point, I'm going to say this is 88. I'm going to round this just like I'm going to round it to the 10th place just like they did. And I'm going to say it's 88, right? That 9 rounds up because of the 6 right there, making this to be a 0, which means this has got to round, this next one has to go up to 88. 88 meters squared. I'm going to call it 88.0 meters squared. 88.0 meters. No, wait. I hope you caught me. Sometimes I do this. I get distracted. Remember, circumference is a length. Circumference is a length. It's not squared like area is. It's not a amount of surface area. So this is just 88 meters, not meters squared, just 88 meters. C equals 88 meters. And then we'll do area. Area next. Well, it's going to be pi times our radius, which is 14. Pi times 14 squared. Once upon a time, I probably could have given you a rough estimate of that, but I'm just going to go to my calculator. I hope you just go to your calculator. Don't struggle with this. Oh, and notice that I'm just using the pi symbol on my calculator. Back in the day, we actually had to stick pi in here manually. Let me show you the difference. So my answer for this one is going to be, if rounding to the nearest tenth, I'm looking at the 10th place, that's a 7. I look to the next place over, it's a 5, which means I got to round up. So this is 615.8 meters squared. 615.8 meters squared. And back to what I was saying about the whole back in the day. All right, I'm going to take you a trip on memory lane here. We used to do stuff like this. We put 3.1, and then oftentimes if you are in construction, this is what you're going to do. You're not going to have a fancy calculator like this. In construction, you're going to have a little simple 4 function. You're just going to know what pi is. You don't need to know pi much more than this many decimals in most cases. 3.14 times 14 squared times 14 times 14, because you're not going to have a squared button on your 4 function calculator. And notice how you're going to get an answer pretty darn close to your original one, but notice how it's not quite the same, right? This one, when I'm using a rounded version of pi, gives me 615.4, dropping the hundredths place from rounding to the tenths, 615.4 meters squared, which is, 4/10 of a meter difference, which, that couldn't matter if you were building a swimming pool, or something like that. That could, an expensive project, you might want to go out to more than 3.14. But in most cases, you can get away with 3.14. I just wanted to show you that oftentimes we round pi to 3.14. And then that's the difference, then going to the exact number versus just 3.14. Okay? I'm going to let you handle this one. Find the perimeter and area of this figure. You can do this, right? Perimeter is, this side plus this side plus this side plus this side, or these two sides. It would be length times 2 plus width times 2. That's the shortcut. Find the perimeter of this one. This one's a little bit trickier. I'm going to go over this one for you. So maybe you want to pause, you want to solve this one, and I'm going to give you some just kind of idea of how to do this one. So I've got to find the perimeter and area of this figure here. And the reason why it's tricky is because they didn't give me a number. They gave me y minus 3. Okay, I can do this. This, I noticed right off. First thing I noticed is this thing here is a square. How do I know it's a square? Well, I have a hash mark, hash mark, hash mark. These 4 hash marks tell me all 4 sides are the same. I have a little right triangle here, which means I know this is a square. It's got all four sides the same, and they're all four right angles. So I know that the perimeter is this side length times 4. So what is 4 times y minus 3? Well, remember what we did before. We can't just say it's 4y minus 3 because I have to multiply 4 times y, and then I got to multiply 4 times negative 3, right? So this is going to give me 4y minus 12. 4 times negative 3 is negative 12. So here is my perimeter right here. My perimeter is 4y minus 12. Let's do the area. Let's do the area. Well, what is area? Area is going to be one side times the other side, right? Length times width, or side squared. That's because this is, because this is a square, I could express this as y minus 3 squared, but in this case, I'm actually going to write it out and multiply it because I need to do some distribution, and I'm going to want this. I'm going to want a little more real estate, and my big head's probably in the way of your being able to see what I just did. Maybe I should rewrite it up here. I don't want my big head to get in the way. Y minus 3 times y minus 3. Okay? I don't like how I did that, but okay, I can live with it. Hopefully you can too. So here's how I got to do. Here's what I need to do. I need to do a whole bunch of foiling, a whole bunch of distribution, because there's a lot going on in here. Just like 4 had to be times y, and then 4 had to go into negative 3, I got to do this one step at a time. Y times y, and then y times negative 3. So let me do y times y. Y times y is y squared. Y times negative 3 is negative 3y. Am I done? No. No, I'm not done. Because now I got to multiply the other things together. I got to multiply this negative 3 by y, and then the negative 3 again by negative 3. So I am not done yet. So first is negative 3 times y. I got another negative 3y. And then negative 3 times negative 3. Well, that's going to be positive 9. A negative times a negative is a positive. 3 times 3 is 9. Okay, am I done? I'm not quite done yet. And for some of you are like, oh my gosh. Listen, sometimes when you're thinking logically, there's a lot of steps, right? I got to combine like terms. These two terms here are like terms. They're both being multiplied by y, so I can combine them. I can add them together. Well, negative 3 plus negative 3 is negative 6. So negative 6y plus 9. This is now my final answer. The area is going to be equal to y squared minus 6y plus 9. And if you ever wondered where in the heck could you ever encounter a quadratic expression in real life, it could be when you don't know, when you have an unknown quantity and you're calculating area, right? An unknown quantity calculating area will give you that. All right. So let me see. I am going to erase all this. If you need it, pause it right here. I'm going to erase all this. And then I'm going to scroll down. You can always go back and look at it if you need. Find the perimeter and area of this figure. No, I'm going to let you... Oh, can I let you handle this? This is the one little tricky part of this one here. One of these things is called x. Do I let you handle this on your own? No, because I think we're going to use some Pythagorean here. And I haven't taught Pythagorean to all of you since the attendance has been an issue. Not all of you have seen this. Okay, so Pythagorean theorem. There is this thing, and I know you've seen it before. But you probably haven't used it in a while. You're probably rusty with this one. This is called the Pythagorean theorem. Some ancient Greek guy came up with this. All right, so here's what I'm going to do. I would really like to know what x is. I would really like to know. And I can figure this out. Actually, I'm not sure if they want you to do it this way. Yeah, we can do it. What the heck? What the heck, right? We're all adventurous here. All right, so what this is, A and B are, what I'm going to do right now is I'm going to see, the reason why I'm not quite sure is I'm just going to assume this is a right triangle. I'm going to assume it's a right triangle, because remember, you can only do Pythagorean theorem on right triangles. All right, so I'm going to assume this is A, I'm going to assume this is B, and then this whole thing here is C, okay? This whole thing here is C. I know that A squared plus B squared will equal C squared. So I know A, I know B. What I don't know is the whole length of this. It's C squared, okay? Well, 5 squared is 25. I just know that through memorization. 13 squared, I'm going to go to calculator. I think it's 169, but I can't remember for sure. It's 169. All right, 169 equals C squared. I'm going to go to my handy-dandy calculator again, and I'm going to say, well, what's 25 plus 169? 25 plus 169 is equal to 194. So here's what I know right now. I know 194 is equal to C squared. Now this is where a lot of you can get this far, and then you kind of will get stuck right at this last little step because you're not comfortable with how to get rid of a C squared. Well, this is how you get rid of a squared. Now let me show you how this works. What's 5 times 5? Well, that's 25, right? That's equal to 25. What is 5 squared? Well, that's the same thing as 5 times 5, 25. Well, then what is the square root of 25? So the square root of 25 is 5. If you don't trust me, use your calculator. Oh, okay. Notice that square root right here, undoes squaring. Square root, right? I squared 5 to get 25, and I square root it, and I get 5 again, like what I started with, right? So, but if I know that C, I don't know what C is, but I know that I have C squared, which is the same thing as C times C, and I know that if I square root it, the square root of C squared is just going to be plain old C. So by putting a square root here, I can just say C, which gets rid of this. This thing here, these two things cancel each other out. And I can find out what the square root of 194 is. Let me go to my calculator over here, because it's a little faster than my calculator over there. 194. It's 13 point, if I'm rounding nearest 10th, 13.9. 13.9. So this is 13.9. Okay, that's the whole length. The whole length is 13.9. How do I find out what x is? Well, I know that the whole thing is 13.9. Again, this is the logical thinking. The whole thing is 13.9. So I can figure out what x is by subtracting 3 from 13.9. 13.9 minus 3 is 10.9. So suddenly I know that this is 10.9. I know the whole thing. It's going to be 13.9. And then, now that I've gotten you this far, I'm going to let you find the perimeter and area of this on your own. All right? Little Pythagorean formula review. Now that you know the base is 13.9, you run with it from there. Find the perimeter and area of this. I am confident that you got that. We already did some circle work. If you don't remember how to do that, I'll let you know. Go back and review. We'll rewatch the examples I've already done. I'm going to let you do this. Please try to use the pi symbol on your calculator to get the more accurate number. I'm going to let you do that. Let's see. Manufacturing. So, you might want to pause the video and you might want to do these other two over here, okay? Let's see. This puzzle here contains a triangle piece with a base of 3 inches. So 3. Ooh, I don't need to do a sketch. They gave me a sketch right there. And a height of 4. 4 inch. Manufacturer wants to make 80 puzzles. Find the amount of wood used if each puzzle contains 20 triangular pieces. So how much wood is this puzzle maker going to need to create 20 triangular pieces in a triangle that looks like this? So remember, we're really talking about area here. We want to find the area of the triangle. The area is going to be the base times the height times 1/2. So the base is 3 times the height is 4 times 1/2. That's going to be 6. So the area of each triangle is going to be 6 inches squared. And he wants 20 of these things. I think you can take it from there. Geography. Also, we can talk about some, right? I know that the Earth is not a perfect sphere. You and I both know that the Earth is somewhat smushed. They call it an oblate spheroid. It's all right. All right, so we're going to consider it roughly spherical for all intents and purposes here. All right, the radius of the Earth at the equator is approximately 3,964 miles. So literally, if you found the center of the Earth and you went from the center of the Earth all the way to the surface of the Earth, you would find that the radius here would be approximately 3,964 miles. You just learned something today. You had no idea how deep it was to the center of the Earth. Right now, wherever you're standing, if you're standing on level ground, if you dug 3,964 feet underground, I'm sorry, not feet, woohoo, that'd be easy. If you dug 3,964 miles underground, you'd be at the exact center of the Earth. Isn't that cool a thing to know? Now, find the distance around the Earth at the equator. Use the pi key on your calculator. So I want you to find, if you know the distance, if you know if you know the distance of the radius here, you should be able to find the distance around the Earth from the equator. So remember what the relationship is, right? We're trying to find. So let me try to think about this. If we look at it from the top, there's the center of the Earth. We know that this distance here is 3,964 miles. Okay, that's the radius. We know the relationship of the radius to the circumference is 2 times r times pi, right? 2 times r pi. So we would have to do 3,964 times 2 times pi to find out the circumference of the Earth. All right, I'm going to leave you to it. And we are now at this point, we're now at our check for understanding. And I'm not going to help you with these at all. These are the real test to see if you've got it. When I want you to find the perimeter and area of this triangle right here. Ooh, did I give you a repeat? Oh, maybe that was a freebie. I want you to find the circumference and area of this circle here. And I want you to find the, this is going to be a real test of your algebra skills and of your geometry skills here, because you're going to have to be multiplying together some binomial expressions together. I know this you guys struggle with this. So this is the check for understanding. 3 questions. Finish these on your own, and then there's some multiple choice here for your enjoyment. Tell me how things went. You're not in a group right now, so scratch this. This was for the classroom. When I first designed this, I was hoping to have this for the classroom. Tell me how successful you were at reaching the learning target. Remember, the learning target was that you can use formulas. To find perimeter, area. Right? I can apply formulas for perimeter, area, and circumference. All right, that's the learning target. Tell me how well you achieved that learning target. Tell me what kind of effort you put in to learning this. What's one thing you learned today? Maybe you learned something about the Earth and how far it is to the center of the Earth. Let's see. Give me any feedback here. And I've got some little extensions. These are extra credit. You don't have to do these. I won't count them against you. So, but I give extra points if you do them. It's a landscaping problem, and that wraps us up. Don't forget to click submit to save your answers here, and we're done. We're done for the day. Woof! My hand hurts from holding that board for so long, and I hope you had a good day today. All right. I hope you're doing well. I hope you're staying safe. I hope everyone you care about is healthy. We're going to get through this. The learning doesn't stop just because school isn't open right now. All right, one day at a time, and we'll move forward, okay? can't wait to virtually see you all in the Zoom conference every Monday through Friday for 2 hours. I'm in Zoom. I'm available at Zoom conference. Email me if you need a different time. I'm usually in there from 12 to 1 on my own personal math Zoom, and then I'm from 1 to 2. I'm with some other teachers, and for any student that needs help. Yeah, catch you on the flip side.